Hello, my name is Muhammad Amrul Akmal and I'm representing Group 11. In this part, I will explain the values selected for vibration analysis and how they were modeled in ANSYS for vibration. So for design 1, different stiffness value were selected from the table to represent different coupler material with K1 values of 450 kN per meter, K2 650 kN per meter and K3 250 kN per meter. So for design 2, the same material was assumed for all the coupler with a value of 350 kN per meter. Perform the validated in ANSYS, both meshes were modeled as solid steel block with a density value of 7,850 km per cube. The required volume were calculated from the mass density relationship and simplified as cubic geometry. The results in cube dimension of 562.885 mm for mass 1 and 575.980 mm for mass 2. The ANSYS software, so we select the model analysis, then we set the geometry. Since I have done for the design 1 and design 2, let's go through what I have done. For the kit 1, the dimension is 562.885 for length, width and height. Then we do the mass 2, which has the dimension 575.980 for length, width and height too. And the distance for both masses we assume 1000 mm. Model. So make sure we choose unit correctly. So first we set the material into the structural steel. Next we set the spring connection, which is K1. We set it to body to ground, which is 450 Newton per millimeter. For K2 body to body, which is 650 Newton per millimeter, and for K3 body to ground, 250 Newton per millimeter. So then we generate the merge. Then we set remote displacement, which only X component free and others fixed with 0. Then we go to analysis setting, which is we set the maximum mode to 2. Then we solve and we get for design 1 the material frequency. For design 1, the first answer is 2.4388. Second is 5.3993. And to get the mode shape, we must divide M2 over M1, so we get positive value. Because as you see, it moves in the same direction for the mode shape 1. So for the mode shape 2, we get negative value because they goes into opposite direction. So for design 2, we just repeat the same step as the design 1 we have done. The only change is the stiffness, so we set it into 350 Newton per millimeter. Then we solve and we get natural frequency. So the first natural frequency we get 2.472. For a second natural frequency we get 4.2866. So the first mode shape we divided into M2 over M1. Then we get the positive value because they go into same direction. So for the second mode shape, we get negative value because they move into opposite direction. So this is our result that we get in the simulation ANSYS. It is the same as the manual calculation done in chapter 3. So that's all for me. Thank you.